Hello and welcome to this new lesson in which I'm going to teach you how to create an LCD shield for Arduino Uno board. First, open up Fritzing and head to the PCB tab. Click on this board and from the bottom right corner choose Arduino Shield. Now go to the Arduino group tab here on the right and drag the Arduino Uno above this. As you can see, you have to drag the original board above your own Arduino so that it matches the same size. Now that we did this, we have to go to the schematic tab. Here is our Arduino. Now let's rotate it. Here it is. What we need to do now is simply go here to the core and drag an LCD. Here is the LCD that we want to connect. Let's rotate this board so that we can connect the data pins together. Now, what we need to do is connect the data pins. I'll start by connecting, let's say, let's flip it. Now, here we have data pins. From D4 we are going to connect it to D5, so let's move it here and DB to the D4, D3 to DB6. It's a 4-pin data mode. Okay, D2 to DB7. Now we have connected from D4 to D7 to the Arduino Uno. What we need to do next is connect the enable and RS pins. The enable can be connected anywhere. Let's connect it to the pin, okay, to D11 pin. And let's connect RS to D12. Now pins number 1 and the RW pin, okay, are connected together. And they are connected to ground. So if you want to move the board like this with the hand, just click on the space bar button. Now let's connect the ground pin to these 2 pins. Now we have connected the VSS and RW to ground. We have to connect the VDD to 5 volts. Here is the 5 volts and here is the VDD pin. Okay, let's drag it here for easy access. And let's change the coloring to red. Right click, wire color red means 5 volts, black means ground. Now that we have connected the VDD, we have to connect other pins. The LED plus must be connected to 5 volts. You can connect it directly or you can use resistor, 5 kilo ohm resistor. Depending on your needs. Now we need to connect the LED minus button to the ground. Let's drag it and change its color to black. Okay, now there is only one pin, which is V, as you can see, the contrast adjustment V0. So we have to connect this to a potentiometer. You can connect it directly to ground if you don't want to control the contrast, but if you want to control the contrast, you have to connect it to a potentiometer. So let's drag this potentiometer. Let's rotate it. Okay, flip. Okay. Now here it is. What we need to do now is simply connect this side, okay, to ground. Okay, like that. Now we need to connect the V0 pin to this side. We can change the coloring if we want to make it more clear. Let's add a yellow color. Now we need to connect the other side of the potentiometer to 5 volts. Let's change the wiring. Okay, now it's red. That's it. This is how to connect your LCD to your Arduino Shield. Now let's go back to the PCB design and adjust the location for each of these elements. Okay, now let's drag the potentiometer here and let's drag the LCD a little bit outside. Okay, now the potentiometer needs to be rotated. That's it. Now let's do auto routing. As you can see, it's connecting different wires and it's trying different ways to reach all of these wires. Now the routing is completed. Now if you didn't like the auto routing or you feel that you don't need double layer PCB, you can change this from the routing section. Now let me undo this. Now if we click here, as you can see, the PCB layer is top. Now if you went here in the routing section and click on the auto router settings, you can choose professional, home pro, or custom. You can choose from custom the keep out, which is the distance between copper elements on different nets in millimeters or in inches. You can choose the size to be home etched or standard for the holes, the hole diameter, the ring thickness. If you need to edit any of these settings, you can. And the hole diameter means this hole, the hole for each of these pins. I prefer keeping them to the default settings. And after that, you can change the ground fill. If you want the PCB to have copper, a lot of copper, you can choose to copper fill top and bottom, ground fill on top and bottom, or you can choose ground fill seed or clear it. This can be used when you have high power boards. You can keep the copper on most of the board for ground or power. Now set both copper layer clickable, or set copper bottom layer clickable, or set copper top layer clickable. You can choose which of these boards you want to be clickable. Mostly we can use the top layer, and you can change the auto routing settings from here. Again, let's do auto routing. As you can see, it's trying to auto route all of these pins. Now after auto routing, you can go to the routing and click on the design rule check to know if there is errors. As you can see, it's checking the routing. Now it's telling us that this pin is too close to the border, and another pin, it's too close to the bottom and top layer. So let's drag this item and let's try auto design rule check again. Okay, now it's telling us that there is parts that overlap. This is because we are placing the LCD above our design, but this won't cause a problem because we have room for the LCD on that shield. You can, however, try to move away these wires from the pins because auto routing, as you can see here, don't keep the, if you want to adjust the bottom layer, these yellow wires are on the top layer, as you can see. You can edit them, while these orange wires are on the bottom layer. So if you want, you can edit the bottom layer or the top layer, or edit both. Here, as you can see, I'm editing on bottom layer and top layer at the same time. We can move this away. Again, this is the way. Now you can move to top layer, move wires to top layer or to bottom layer depending on your needs. Let's check the errors again. Now it's telling us that these wires are overlapping each other. As you can see, we don't see them. Okay. Let's check again. Design rule check. Your sketch is ready for production. There are no connectors or traces that overlap or are too close together. Now we did clean our design and everything is good to go. You can simply print that design and create your own LCD Arduino Shield. Now once you are done, you can simply export your design for PCB and select, let's name it Arduino LCD Shield. Select folder. That's it. You can see that PCB. Okay, let's check it out. Now to see our PCB design files, here they are. You just need to open them using any software. I'll use Foxit Reader for PDF files. This is an empty file. Let's try this one. Okay. These are the pins and these are the wires for the bottom layer, as you can see. And let's see the top layer. Okay. Top mirror. Here is the top mirror if you want to print it out. These are the files that can be used to create your PCB, or you can also export the design. As you can see, this is the schematic and this is the breadboard itself. This is the breadboard view. We didn't connect anything here, so we can remove it. We just use the Arduino pinout and an LCD with a potentiometer. That's it. Thanks for watching this lesson. If you have any question about creating your very own Arduino Shield using Fritzing, please ask in the Q&A board. Thanks for watching. This is Educational Engineering Team.